this video, we're going to talk about identity and inverse matrices. Now, the n by n matrix I sub n with ones along the main diagonal, upper left to lower right, and zeros elsewhere is called the identity matrix of order n by n, meaning the number of rows determines the number of columns. So the identity matrix for a 2 by 2 would look like this on the left. There's a 2 by 2. Here's a 3 by 3. There's a 4 by 4 identity matrix. Now, if matrix A is any n by n matrix, then we can prove that A times the inverse matrix will equal the inverse times A, which is equal to A. That means the inverse matrix is the multiplicative identity for the set of n by n matrices. Now, if A is a non-zero real number, then A inverse is equal to 1 over A. That's a multiplicative inverse of A. That is, A times A inverse equals A times 1 over A, which is equal to 1. Now, the definition of multiplicative inverse of a square matrix is similar. So in order to prove that if two matrices are inverses of each other, you multiply them together both ways, so A times B and B times A, and you get your inverse matrix, your identity matrix. That means B is the inverse of A, and A is the inverse of B. Now we'll see that not every square matrix has an inverse. If the square matrix A does have an inverse, then A is non-singular. If it has no inverse, then it is singular. So let's start off by multiplying A times B. 3, negative 1, negative 2, and 1. Times 1, 1, 2, and 3. So we're going to multiply these. So we'll take 3 times 1 plus negative 2 times 1 plus 3 times 2 plus negative 2 times 3 plus negative 1 times 1 plus 1 times 1 plus negative 1 times 2 plus 1 times 3. So when we simplify this, we will actually get 3 plus negative 2 is 1. 3 times 2 is 6, plus negative 6 is 0. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 2 plus 3 is 1. So therefore, A times B does give you the identity matrix. Now if we do B times A, again, rewrite them to make it easier. Sometimes your brain doesn't see it the way you want it to see it. So we're going to multiply. So without showing all the work, we'll have 3 plus a negative 2. Negative 2 plus 2. So 1 times negative 2 is negative 2. 2 times 1 is 1. 1 times 3 is 3. 3 times negative 1 is negative 3. 1 times negative 2 is negative 2. 3 times 1 is 3. So when we do simplify this, we'll end up getting 1, 0, 0, 1. So this tells us then that AB is equal to BA, which is equal to the identity matrix of a 2 by 2. Now for B, again, we're going to do A times B. So we multiply these. 2 times 0.8 is 1.6. 1 times a negative 0.6 is a negative 0.6. 2 times negative 0.2 is a negative 0.4. 1 times 0.4 is 0.4. 3 times 0.8 is 2.4. 4 times negative 0.6 is a negative 2.4. And then 3 times negative 0.2 is a negative 0.6. 4 times 0.4 is 1.6. Now, using your math skills, we should see that we get 1. Should be a negative 0.6 here. We should have 1, 0, 0, 1. Now for BA, we'll take 0.8, negative 0.6, negative 0.2, and 0.4. Multiply by 2, 1, 3, 4. So when we multiply these, 0.8 times 2 is 1.6. Negative 0.2 times 3 is a negative 0.6. 0.8 times 1 is 0.8. Negative 0.2 times 4 is negative 0.8. Negative 0.6 times 2 is a negative 1.2. 0.4 times 3 is a positive 1.2. Negative 0.6 times 1 is a negative 0.6. 0.4 times 4 is 1.6. Using your mathematical know-how, you can see that we get 1, 0, 0, 1. So this tells me then that AB is equal to BA, which is equal to the identity matrix of a 2 by 2.